binomial expansion. In this lesson, we're going to talk about different ways of expand binomials. Now, there's a shortcut if you have the binomial expansion memorized for the squares and cubes. But really, what most people do when they have to expand something like this, they just multiply by itself. X plus 1 squared is x plus 1 times x plus 1. You distribute, and you get x squared plus 2x plus 1. X plus 1 cubed, like x plus 1 times x plus 1 times x plus 1. And you get something like this, and then how do you multiply this out? Well, you have to do it pairwise. Multiply these two first, get your answer, multiply by that one. You actually know what this is already. X squared plus 2x plus 1. Then you multiply that by x plus 1, distribute again, and get your answer. Right, and you get x plus 1 to the 4th, much the same way. X plus 1 to the 9th, much the same way. Just gets really, really tedious. So there must be a better way of doing this, and there is. It's called a binomial theorem. Now, it's not much shorter, but it is a more of a mechanical way of doing it all. It gives you much more better form of following it than just multiplying stuff together. So it's easier, more straightforward, but not much faster. It looks a little bit faster. Anyway, here's the binomial theorem. This is straight up from the formula sheet. So a plus b to the n is a to the n plus n to c1. That's the binomial coefficient right here. Remember to use the formula last time. A minus 1 times b, blah, 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 blah. Honestly, I don't use the formula that much. I mean, I use it, but I don't follow it. So I'll say what I mean. It's really, you want to build your binomial. And so that's the way we're going to do it. So the formula is really just, you want to write, okay, so the key thing is what power we're going to the third power. So we're going to write this. 3, 0. So this is the first term. 3 to 0. So the 3 there to the very first term. And then x and 1, right? So the first term, second term. Then we're going to keep on going. 3, 1, x, 1. 3, 2, x, 1. And then we keep on going until they match. 3, 3, x, 1. So like that. Right, so you can see here, so NC1 for us, our n is 3, so it's 3C1, 3C2, 3C3. So that's all you do. Whatever power it is, 3, you put that power over 0, keep on going till they match. Now we set the powers of these guys, you can kind of see there. So the way the powers work is like this. Whatever the bottom number right here is the power of the second one. So 1 and 1, 2 and 2, 3 and 3. Like that. And then the power of the next one, right? So like you can see here, n minus r, r, n minus 1 and 1. What's going on is the power of these two things add up to be whatever power you're talking about. So here, 1 plus what equals 3? That should be 2. Right? 2 plus 1 equals 3. 3 plus 0 equals 3. And then over here, 0 plus 3 equals 3. So that's all it is. You start with whatever power it is over 0, first term, second term. Keep on doing that till the powers match, 3 over 3. And then the way you do the powers of these guys, it's the bottom one has to match the power of the second. Then these two add that up to be the top number. So 1 and 1, 1 plus 2 equals 3. 2 and 2, 2 plus 1 equals 3. And once you do all this, now what we have to do is expand now. We can simplify this. If you're wondering what's 3, 0, remember that is 3C0. So you could do it with mathematics, or if you have Pascal's triangle. This row right here is row 3. Particularly this is 3C0, 3C1, 3C2, 3C3. So this is 1 using Pascal's triangle. This right here would be 3, 3, and 1. Right, it's using Pascal's triangle right there. And then we just simplify the rest. So x cubed is just x cubed. Anything to the 0 power is automatically 1. So keep in mind, all these things get multiplied. So then plus, and this section, x squared, 1 to the 1 is 1. Plus x to the first, or x, 1 squared is 1, plus x to the 0 is automatically 1, 1 to the 1 is 1. So we have this, and then we just simplify this. X cubed plus 3x squared plus 3x plus 1. And that's how, and we expand it using binomial theorem. Let's do another one real quick. 3x plus y to the 4th power. So we're going to start the exact same way. So whatever the power is, I'm going to do 4 over 0, first term, second term, plus 4 over 1, first term, second term. A little sloppy there, sorry. Okay, keep in mind the first term is 3x. That's the first term, this is the second term. 4 over 2, 3x and y, 4 over 3, 3x and y. A little sloppy again. And then 4 over 4, 3x and y. A little sloppy at the end, run out of space. Let me make it a little smaller so that we can all see. Let's make that a little bit smaller so we can all see it. There we go. Okay. So like that, right? So always the same thing. Whatever the power is over 0, first term, second term. Keep on writing that until you get the powers match. So in this case, 4 over 4. Next, we do the powers, right? So bottom power matches the bottom matches the power of the second one. So 0 here. 1 and 1, 2 and 2, 3 and 3, 4 and 4. Like that. And then these two have to add up to be this number up here. So 0 plus 4, 1 plus 3. Now, a lot of people say the first one counts down, the second one counts up. I don't like that for a very specific reason, which you'll find out in a second, but it does work when you do the whole expansion. But again, I like to do 2 plus what equals 4. So that's 2, 1, and 0. And then once you get to this part, all you do is simplify the rest. Now, 4, 0, 4, 1, 4, 2, you could do binomial theorem, binomial expansion, or you could just use Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and the one I need, 1, 4, 6, 4, 1. Right? 1, add these up, add these up, add these up, 1. And so it's going to work the exact same way we did last time. This is 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. So this would be 1, 4, 6, 4, 1. Right? This row matches these guys. So we got that. And then we just got to simplify this part right here. Now right here you have to watch out. 3x to the fourth. That is not 3x to the fourth. It's all of this to the fourth. So it's 3 to the fourth and x to the fourth. That gets me 81x to the fourth. Anything to the power is automatically 1. So that's 1. So that's that one. Remember, all this gets multiplied right here. The next one, same idea. All this is cubed, so 3 cubed and x cubed, which gets me 27x cubed times y, because it's y to the first. Over here, again, these all get squared, so 3 squared and x squared. So times 9x squared, y squared, plus times 3x times y cubed, plus anything to the 0 power is automatically 1. So all I have here is a y to the fourth. Right, so we get that far, and then we just simplify each little term. So this is ax to the fourth. This is, what, 28, 2, so 68. What am I talking about, 68? 108 x cubed y plus 54 x squared y squared plus 12 xy cubed plus y to the fourth. And it's fully expanded. So that's how you fully expand using binomial theorem. Lucky for us, we generally don't ask you to expand it the whole way. What we do instead is ask you to find a single term. So like this one here. They want you to find the sixth term of this expansion. So all I gotta do is find the sixth term. Now, key thing to keep in mind, if they want you to find a single term, we start at 0. So like up here, right? Here's my first term, second term, third term, fourth term, and fifth term. So my first term for this would be 10 to the 0, then 10, 1, 10, 2, 10, 3, 10, 4, 10, 5. That's my sixth term. So my sixth term is going to be the expansion of 10, 5. Right, once I know it's 10, 5, which is, it's generally always be one less. I could do the rest. If that's 10, 5, then I write the first term C and the second term D. I should know these powers, right? The power of D is always the same as a bottom number here, so 5. And then right here, these two should have to be that number. So 5 plus 5 equals 10. And then we just got to expand. 10, 5, I don't know that. I would use my calculator. So I'll use 10 on 10 math, probability, NCR, and 5. So I get 252. C5, D5. There we go. Let's do another one. They want the sixth term of this. So now we know the sixth term is going to be one less. So this is going to be, I guess not 10 because we're doing 8 here. 8, 5. That'll be the sixth term, right? Because we do A0, A1, all the way to A5. That's the sixth term. So we can do the whole thing all over again. That's the sixth term. So we just got to expand that. A5, first term is 2C, second term is negative 3D. And again, we know what this looks like. The power here is the same thing as the bottom power here, so 5. These two should have to be that number, so this must be a 3. And then simplify. This 3 goes to both of them. This is 2 cubed C cubed, so 8C cubed. Over here, that 5 goes to everything. Negative 3 to the 5th is 243, negative 243, and D to the 5th. 8, 5. I should know that one. I don't have it off the top of my head right now, so I just use the calculator. 8 math and CR and 5, 56. And then if I want to simplify all this, just multiply all the coefficients. So 56 times 8 times negative 243. It's going to be a big number. And I get that. Something like that. Right, then we could expand go for a little bit further. What if I just want to find x cubed in the expansion of this? So I don't care what term, I just want to find x cubed. These are some of my favorite problems. So the way we do that is write down what we know. So I know the power they want me to do is 11. So when we write out our expansion, right, that's always the top number here. And I know the first term is 1, and the second term is 2x. So like, you start with the base. What do you know? Okay, I know my power is going to be 11 up there. My first term is 1, my second term is 2. And then what do they want? They want x cubed. Well, how do I get x cubed in this thing? Well, I have to make x to the third power. And that unlocks everything else. If I know I need that to be x cubed, now I know, well, this bottom thing has to be cubed 3 also, because these two always match. And this number has to be 8, because 3 plus what equals 11. So you get that, and then we just expand it. 11, 3, don't know. I have a calculator though. 11 math and CR 3, so 165 times 1, that's what this is, times, remember this cube goes to both of them, it's 2 cubed x cubed, 8 x cubed, which is, multiply those two out, so that times 8, probably should know that, 1320. So like that. Again, I love these questions. So look at the next one, same idea. They want me to find x10 in this expansion. So again, write out what you know. I know that my power here is 10, that's what this is. I know the first term is 3, and I know the second term is 2x squared. Now they want me to find x10. So here's the thing, if I put a 10 here, what happens? 10, you multiply the powers, you actually get a 20. I only want x10. So what I gotta put here is a 5. That way when I multiply these out, when I distribute, I get x10 total. Well, if that's a 5, that means this is a 5. And actually, this is a 5 too, because 5 plus 5 equals 10. Then we just expand. 10c5, 3 to the 10th, that 2x squared to the 5th. I'll let that go now, because that's going to be a huge number. And to save a little time, let's let that go. Next one. Now we get to more difficult ones. Write down the first three and the last 2 terms of this expansion. They don't want us to simplify. So let's talk about how you simplify this expansion. So let's look at this. It's to the 12th power, but that's not what's interesting about it. What's interesting is the second term is 1 over x. Doesn't matter though. So start the same way. Let's do the first term. First term is 12 over 0. First term. Second term. They want the first 3, so plus 12, 1. 12, 2. So those are my first 3 terms. And they want the last 2 terms. So my last 2 terms will be 11 and 12. So 12, 11. And 12, 12. Again, I'm running out of space. I'm very bad at figuring out how much space I need. just like that. And then I still have to do the powers. So the bottom power matches the second one. Like that. And then remember, these two powers have to add up to the top number. So 0 plus 12 would give me 12. 11, 10. Over here, since it's 11, this must be 1. And since it's 12, this must be 0. And there we go. Again, notice we do not want to simplify our answers, so we're going to simplify down. Now let's go to the fun ones. Find the 7th term in this thing here. This is actually not that bad. The 7th term, remember, if we're talking about terms, it's always one less. So my first term would be 14, 0. That's the first term. Right, 14, 1 would be my second term. 14, 2, 4, 14, 3 is my fifth. 14, 4 is my, I miscounted somewhere, huh? Yes, I did. Sorry about that. I was like, that's not right. 3, 4, 5. It's always one less. 14, 5 is 6, and I want 14, 6. Again, you don't have to do this every single time. If you know it, I have it memorized. If you have it memorized, it's always one less. You just expand this one. So we need to expand 14, 6. Right, so if I know that's the value I want, then first term, 3x. Second term, negative 4 over x squared. And then let's do the powers. So that's a 6, so this must be a 6. And since that's a 6, that's a 14. 6 plus what equals 14? That is 8. And then you can simplify from there. A lot of putting in your calculator simplifying. I won't simplify the whole way, but I do want to show this part. So if I expand that, I get 3 to the 8th, x to the 8th. We'll leave this 14 over 6. What about happens here? Well, that 6 goes to both of them, so it's a negative 4 to the 6 and x to the 12th. Right, I multiply this and this. So x to the 12th. So if I actually would expand this, I get some number. What's the power? 8 minus 12. When you subtract these, and I get x to the negative 4. That would be the power of this. Because this gets you 8. You multiply the powers, you get 12. 8 minus 12 is negative 4. The rest is just all numbers in the calculator. Okay. Now the actual one wants to find the expansion of this. So let's find the coefficient of x to the 6th. And then the constant term code for x to the 0. That's all that means. Okay, expansion of this. So we write what we know. I want 12 something x squared 4 over x. That's all I know. Now, in this case, it's not as easy to figure out what do I need to put here to find x to the 6th, because there's an x on the bottom, it changes the math. So what we mostly do is this. We set up an equation. We'll let this be a and let this be b. And we have to make up two equations for this. First one I know, if I add a and b up, it should equal 12, because remember that's the rule. This plus this equals this. So that's my first equation. Now the second equation is what are the powers I get? I'm looking for x to the 6th. So let's look what happens with the powers here. So let's rewrite this a little bit. Now I only care about the powers. So how do I get the power here? I multiply these together and I get 2a. How about the power here? You multiply them together and you get negative b. And when I add these powers up, I'm looking for x to the 6th. I'm looking for 6. So that's my equation. It's a plus b equals 12. And then look at the powers. 2a, multiplying those together, and negative b, multiplying those together. When I add those up, I want to get x to the 6th. And this is an easy equation to solve. You add down, you get 3a, these cancel, equals 18, and you get a equals 6. So I know what my a is. That's 6. If that's a 6, this must also be a 6, because those two have to be b. If that's a 6, this is a 6 down here. So I have to expand 12, 6, x squared to the 6, 4 over x to the 6th. And then from this, you just have to multiply it out. Let's do it real quick. Right, 12, 6, again, not totally sure, so I'll use my calculator. 12, math, turn on, sorry. 12, math, NCR, 6. I get 924. Over here, I get x to the 12th. Over here, I get 4 to the 6th over x to the 6th. Right, just multiplying this x to both of them. your x, these two cancel, reduce, and you get x to the 6, right? 12 minus 6, one's on top, one's on bottom. These two things just multiply. So 924 times 4 to the 6. And we get that number, 3784704. Now notice what the question was, find the coefficient of x to the 6. I actually don't want x to the 6, I just need this, the coefficient of it. And that's it for now. We'll finish the rest in class.